Welcome to Leonard and Asad. This is the fourth lesson of exponents and surds, and today we're going to be exploring one of my favorite sections in this topic, and that is exponential equations. Now, when working with exponential equations, you're going to be working with unknown indices or variables or exponents, whatever you want to call it, and your main objective will be to make the unknown variable or index to be the subject of the formula. So the one and the only way of doing so is to make sure that the bases are the same. Once the bases are the same, you can equate the exponents and then find the value of whatever variable that you are working with. Okay, so for example, if you have a to the power of x equal to a to the power of y, seeing that the bases are the same on either side of the equation, you can go on to equate the exponents. So that will be x equal to y there. Alright, so let's take a closer look at an example to see how this works. Alright, let's say maybe you have 2 to the power of 2x equal to 2 to the power of 6. Now that the bases are the same on either side of the equation, what you can do, you can equate the exponents and say, alright, 2x will be equal to 6, and then from here you can divide both sides by 2 so that you can find the final answer of 3 there. Alright, so that's typically how you can solve an exponential equation. Now let's take a closer look at a situation whereby the bases are not the same. How can you solve a problem like that? Okay, let's say maybe you have 2x equal to 4x plus 1. How can you solve this problem? Well, in this case, 4 can be written as 2 to the power of 2, and that will be raised to the power of x plus 1. And then I'm going to drop 2x on the left hand side there. Alright, so the bases are now the same on either side of the equation. So 2 to the power of 2 multiplied by x, that will be 2x plus 2 multiplied by 1 there, that will give you 2. Alright, and then on the left hand side, I'm still going to drop 2x. So now that the bases are the same on either side of the equation, I can now go on to equate the exponents. So it will be x equal to 2x plus 2 there. Alright, so from here I can group the like terms, so it will be x minus 2x equal to 2. And then what is x minus 2x? That will give you negative x equal to 2. And then the final answer there will be x equal to negative 2. Alright, so that's how you can actually attempt an equation or a problem that has bases which are not the same. Alright, now let's take a closer look at the next example to see how we can actually attempt it. Let's say maybe you have a to the power of x plus 1 equal to 32 divided by 4 to the power of x. Now it's the same principle even here. What we have to do, we need to make sure that the bases are the same. So 2 in this case can be written as 2 to the power of 3 there, and then that will be raised to the power of x plus 1. Okay, so it will be x plus 1. So 32 can be written as 2 to the power of 5. So 2 to the 5 will give you 32, and then that is divided by 4 to the power of x there. But 4 to the x can be written as 2 to the power of 2 raised to the power of x. Alright, so now on the left hand side we will have 2 to the power of 3 multiplied by x. That will give us 3x there. And then what is 3 multiplied by 1? That will give us 3. And then we are going to drop 2 to the 5 there, divided by 2 to the power of 2x there. So from here our bases are the same, but just before we can equate our exponents, we need to solve something on the right hand side, because if you can check very clearly here, we have a diversion sign. So according to the first rule, or the rule that we learned about on the first lesson, it said that whenever you divide the poles of the same base, what do? You subtract the exponents. Alright, so that will be 2 to the power of 5 minus 2x. So it will be 2 to the power of 5 minus 2x. And then on the left hand side, we are going to drop 2 to the power of 3x plus 3. Alright, now our bases are the same on either side of the equation, so we can equate the exponents. So it will be 3x plus 3 equal to 5 minus 2x. And then from here we can group the like terms, so it will be 3x plus 2x equal to 5 minus 3. Alright, and then what is 3x plus 2x? That is going to give you 5x. Alright, so it's 5x, and then what is 5 minus 3? That will give you 2. So our final answer will be x equal to 2 divided by 5. I just ran out of space, but okay, let me just do like this. Our final answer will be x equal to 2 over 5 there. So that's how you can actually solve exponential equations. Alright, now let's take a closer look at this last example for today's lesson. If you have 2x plus 2x to the power of, or rather 2x plus 2x plus 1 equal to 24, how can you simplify this? Well, as you all know now, that the first thing we have to do is to make sure that the bases are the same. But unfortunately, 24 cannot be written as an exponent of 2, so therefore the only way of simplifying this expression will be to take out the highest common factor on the left hand side. So that will be 2 to the power of x plus 2 to the power of x multiplied by 2 to the power of 1 equal to 24. Alright, now what I've done here is that I've used the rule saying that when you multiply the poles of the same base, you add the exponents there. Okay, so when you multiply 2 there, it will be 2 to the power of x plus 1. Alright, so this would have done here, but I just reversed this rule here. Okay, so I didn't use the traditionally. Alright, and then from here I can take out the highest common factor of 2x, and that will leave me with 1 plus 2 to the power of 1 equal to 24. And then what is 1 plus 2? That will give me 3. Alright, and then that was multiplied by 2 to the power of x equal to 24. And then what is 24 divided by 3? That is going to give us 8. So that is equated to 2 to the power of x. Alright, now from here 8 can be written as 2 to the power of 3. Alright, so it's 2 to the power of 3, 2 to the power of 3, and then that's equated to 2 to the power of x. So now that the bases are the same, we can equate the exponents. So our final answer there will be x equal to 3. Alright, now can we check if our answer is correct? Sure, why not? So our original equation was 2x plus 2x to the power of x plus 1 equal to 24. So what I'm going to do, I'm going to substitute x with 3 that we found on the previous calculation. So that will give us 2 to the power of 3 plus 2 to the power of 3 plus 1 equal to 24. Alright, and then from here, what is 2 to the power of 3? That will be 8. And then 2 to the power of 3 plus 1, that is going to give us 16 there, because it's like 2 to the power of 4, and then yeah, it'll give us 16, and then that's equal to 24. So we are trying to see if our left hand side will give us the same answer as the right hand side, which is in this case 24. All right, so what is 8 plus 16? That will give us 24 there. So in this case, our answer is definitely correct, because our left hand side is equal to right hand side. Okay, so that's how you can actually work with exponents and surds. They're so easy. They are unlike simplifying expressions, whereby you don't know if it is possible to simplify an expression further or not. Okay, and whereby you don't know if your answer is correct or not. You know, with equations, you can always check if your answer is correct by substituting your final answer back to the original equations. So that's one thing I like about exponential equations. All right, so now that we've done these problems together, I think it's your turn now for you to attempt similar problems to see how much you understood of today's lessons. All right, or today's lesson, should I rather say. Yeah, so just before I sign out, make sure that you subscribe to this channel so that you don't miss out on any of the content that I'll be uploading. All right, now until next time, goodbye.